Okay, so let's see how we did on how the next two work out. So notice on this one how I've got two terms here, but notice that this first term is a square. Now, if you remember back when we were talking about adding and subtracting polynomials, in this one up here, this binomial is linear because it has a degree of 1. So it's a linear binomial. But this binomial, since it has a degree of 2, it is a quadratic. So this is a quadratic binomial times a quadratic trinomial. So regardless though, as far as the process, none of that's going to change. So I'm going to set it up. I'm still going to have a 2 by 3 box because it's a binomial by a trinomial. X squared negative 4, x squared 6x and 5. And now I'm going to find the area of each box. So x squared by x squared is x to the 4th. X squared times 6x is 6x to the 3rd. 5 times x squared is a 5x squared. Negative 4 times x squared is a negative 4x squared. Negative 4 times 6x is negative 24x. And 5 times negative 4 is negative 20. And so when I go to combine like terms, because of the fact that it's not linear by quadratic, it's a quadratic by quadratic, my diagonals are not going to line up. So my largest degree is the x to the 4th, so that's my first term. Then the next that I have is this one cubic term, so plus 6x cubed. Then I do have a 5x squared that I'm going to combine with this negative 4x squared. So 5 take away 4 leaves me with a plus x squared. Then the one linear, so minus 24x, and the constant minus 20. So now I have the area of this polynomial whenever I multiply the two polynomials. All right, now what about this last one? So in this last one, we're multiplying a quadratic trinomial by a quadratic trinomial. So it's a lot more work, and this is the reason why I love the box method. Whenever I have polynomials that are so big, there creates a lot of terms, and it can get messy. The box helps organize. So since it's 3 by 3, I need to set up a 3 by 3 box. So I'm going to have a really big box here. And I'm going to put my 2x squared minus 2x minus 1, x squared plus 3x minus 5. And I'm going to find the area of each of these boxes. So x squared times 2x squared is 2x to the 4th. X squared times negative 2x is a negative 2x to the 3rd. X squared times negative 1, negative 1x. 3x times 2x squared is a 6x to the 3rd. 3x times negative 2x is a negative 6x squared. 3x times negative 1, negative 3x. 2x squared times negative 5, negative 10x squared. Negative 5 times negative 2x is a positive 10x. Negative 5 times negative 1 is a positive 5. Now it's time to start putting like terms together. In this situation, my diagonals are going to match up, and they are going to be like terms, except for Miss Green left off a degree. That should be a negative 1x squared. I was able to catch that because that diagonal didn't match up with those. And so now I have a 2x to the 4th plus 4x to the 3rd minus 17x squared plus 7x plus 5.